Okay, so in this video we're gonna be learning how to recreate a 4-bit adder into active HDL, how to recreate it, and how to simulate it, mainly how to make a simulation out of it. So first, we're gonna make a new workspace. Create new workspace, and it's gonna be called homework. It says that it already exists because I was recording it, but the video got kind of bad, so I'm redoing it. Okay, but the thing is that you're not gonna get this message. You're only gonna get the just next part. So now we got the workspace. In my case, I already got the files from a teacher. He sent us the code. So I could technically recreate it, like naming the design and like putting every single input and exit, but since I already got it, I'm gonna click on add existing resource files. Click on next, add files, and in my case, I got this is the 3 codes to send us, which is complete adder, 4-bit adder, and a 4-bit adder with a for loop. So I'm gonna be choosing this and this. I could choose this and this, but I kind of think it's more interesting to choose this too. This and this are the same, just different download version. I might get the number 1. Okay, so next here, which is default HDL language, which is the default answer, but default option. Then VHDL, because we're not gonna use Verilog, and not defined. Then next, type the design name. It's gonna be called adders. I want it to be in this location, homework. So you can choose the location folder if you need to. So next, classes already exists because of what I told you. It's gonna be others, then final, FNL standing for final. Okay. So finish. Very good. So now we got you click on yes. Then it turns out to have these 2 files, which are the ones that I located before in my downloads. This is the complete sum code. And basically, okay. So here it's using an easier code. It's using ports to simplify the code. So here, instead of having this, like we didn't make it this way, it would be like a 2 dots in std logic, logic, and we would end the statement, and then on there would be like b and the same thing until we got to cin, which is the carry in, so on. So instead of doing this, we just put this port avcin divided by commas. We define as std logic, not vectors, and same thing for outputs. So then, okay, this is our entity. Entity is fa. Here we started and we finished it here. The architecture is called behavioral of the entity. The behavioral is called like this because it shows how the outputs are gonna behave. So the S is gonna be a SOR B inputs, and this SOR carry in, and something for the carry out is gonna be a SOR B, and all this, and carry in, and then all this, or A and B. Again, this is a simple code. I'm gonna compile it because I didn't really modify anything, but since I showed you the difference, then I gotta do this. Then I gotta resave it or compile it, so I have no errors. Then I change to FBA. There's the other code. There's one. Okay, this is basically 1 bit. This makes the sum in 1 bit. So what we want is a 4-bit adder. So we need kind of 4 out of this code. So we would okay. So again, we get the same inputs a, v, and count, and not count. I'm sorry, and carry in. These are important to go 3 down to 0 because we're gonna use that. The carry in is gonna be, okay, these are gonna be vectors, that's important. Though it's gonna be kind of, wait, I'll modify something, yeah. And it's gonna be aesthetic logic, like 1 or 0 basically. This vectors, they use them with different information, different type of information. Then the the exit, I mean, yeah, like the output is gonna be S. It's gonna also be stated as an STD logic vector, and also has to be 3 down to 0. And the carry out is basically the same as the code before here, just different names. So here we end our 4-bit adder entity. The entity is called 4-bit adder. The architecture, the behavioral or of 4-bit adder, which is the behavior of the entity, is here. We're gonna use components also. Components and ports like this here are made to simplify the code, or it would have a longer version of this code which would be exactly the same, but with components we subdivided into little ports to make it easier and faster. So then we state the signals. We state the signal ports as STD logic vectors 4 down to 0. That's also important. And here we begin with the cool part, which is the 4. Okay, 4 is gonna be I and 0 to 3, because it's gonna be repeating 4 times 0, 1, 2, and 3. So we get the 4-bit vectors. The UET is how we use it to define it. And okay, the C comes from the carry in, and it's gonna be stated as 0. And the carry out is gonna be stated as C4, which you're gonna see later. So how do we simulate this? We go into multiple unit, so that we don't only make the simulation from one code. So in order to choose both, we're gonna hold Control and choose the second one, then click on OK. Okay, now we got a multiple unit here. Now we can compile everything, which should be already. Initialize simulation. New waveform. And okay, drag the 4-bit adder here from A to C. We're not gonna drag this one because they're already inherited in here. So our inputs are A, B, and C. Okay, so we choose these 3. No, this and these are outputs, so we're not gonna choose them. So this all the way to here. And right click stimulators. Now we're gonna choose clock from B. Clock, okay, B is gonna be 100 ns. Then from here we're gonna go 1 up to 100. It's gonna be 300 ns. No, I'm sorry. 400 ns. We multiply times 2. It's gonna be a double. So 800 ns. 1600 ns. Nanoseconds. What's this? 6,400 nanoseconds all the way to this calculator real quick. Apply. We apply this, we make sure it's okay. And the current in is, we're gonna set it as a value. Since we don't really use it here, it's not gonna be used. It's gonna be 0. value lesson. And apply. Yeah, now it's 0. Now we can run the simulation. Stop it for a few seconds. We zoom in. Wait, I don't know what I clicked. And here we get the whole simulation. We could also try to use test bench here. And yeah, that's the whole manual for the simulation of this code. Thank you very much. I am Rodrigo Ponce Cortés. My ID is 166400, and I'm studying in the Universidad de las Américas Puebla from the digital design class. Thank you very much.